So we've got our CSV file, which has the time of the video that we recorded, and we've also got the XY coordinates of the beetle. We just have to be a little bit careful when we do our analysis, because we could have started at any time point in this video file. So what we should do is normalize our times back to the start. So the very first data point that we get is time 0. So the way that we do that is I've gone up here and I've named this cell here start, and so if we go start minus start, it will be 0, and then we'll calculate every time point after that relative to start. So here we've got 12 recordings from 0 to 11. So this makes sense because this is the very first position, XY position, that that mouse was in. So we'll call that normalized time. Okay. Now, what my colleague has asked me to do is to say, hey, how do I go about calculating the distance of that mouse at each time point? So where did it move to in the arena? And all we've got to play with is the X position and the Y position for each frame that we've analysed. Let's have a think. How would we go about doing that? So what I'm going to do, we'll just head over this way. Here is another camera, and this camera, I've removed the infrared filter on it, so the colours are going to be a little bit different, a little bit wonky. Okay, a lot of my experiments use infrared illumination. So here we have the arena. So we'll make the arena nice and big, and we're looking at it from the top. And what we do is we have the beetle. The beetle was here, or we've got the mouse. The mouse is located here. Now, I'm not an artist, but that's okay. So here we have the centroid, or the center of the mouse, and we've got the X position of that mouse at time t, and we've also got the Y position at time t. Now, at 1 second, let's say he moves up here, over here. So he's still facing that way. Oh, he got a bit fatter as well, but that's okay. And we found him up here at 1 second. So that will be X at t plus 1 and Y at t plus 1. So this is 1 second, t plus 1, and then this is at time equals 0. So that could be 2 seconds and 1 second, 3 seconds and 2 seconds. So here we're just trying to get a general case here for all time differences. So we need to calculate this distance between here and here. How do we do that? Well, we know that the mouse, or the beetle, has actually moved in this direction by approximately this much, hasn't he? So we've got a delta x here, from here to about here in that second. And we also know that he's gone from here up to around about here in the Y direction. We've got those values in our CSV file. So we've got a Y direction here, so we've got a delta Y, because he's gone from here, about here, down to here. Well, he's gone from here up to here. So all we need to do is, well, we've got a right angle triangle here, don't we? And so if we now plot the hypotenuse here, we've got the distance here. And we know that we can relate in a right angle triangle the distance to the two other sides, the adjacent and the opposite and the adjacent. We've got, oh, getting excited here. We've got Pythagoras. And what this is x squared plus y squared equals, well, this would be z squared, but we're going to call it d squared for distance squared, equals d squared. We're expressing our x in terms of a change in x at time t plus 1 and at time t. So what we can do is we can go change in x squared plus the change in y squared equals d squared. And what we know is that this is actually t plus 1, so that'll be x at t plus 1 minus x at time t all squared, plus, we'll do the same thing for the y's, so t plus 1 minus y at time t all squared here. Okay, so time at t plus 1 minus the position in the y-axis at time equals t all squared, and then what we do is we take the square root of that. Now we square these differences because we want a positive difference. If he had moved down here, if we did the subtraction only, then we'd get a negative change, and that would sort of cancel out. So if we square every difference and then take the square root, we'll always get a positive or a meaningful difference. And then this is the distance at these, between these two time points, t plus 1 and time t. So this could be 1 second and 0 seconds, and we'll get the distance in that first second. This could be 2 seconds and 1 second, and that would be the distance at the first second of recording. So you see, by using this general rule, okay, t plus 1 and t, so this could be 3, 2, 4 seconds, third second, okay, all of them. Now, if we now sum up, okay, from 0 to the max, if we sum up all of our distances, we will then get the total distance travelled. We have these values. We have the x and y positions at each time that we're interested in. So all we need to do is square them, add them, and then take the square root, get the distance for each time point, and then add the guys up, and then we'll get the total distance travelled. So if, for instance, he moved down here now at x t plus 2, y t plus 2, so this is t plus 2, t plus 2, we can do exactly the same thing. He's moved across this distance, so that'll be delta x, and he's moved down delta y. So then we'd get the distance here. So we just have to set up all of the right angled triangles for each of the time points. Okay, so let's move back over here. We'll turn this guy back off. So we've got all this data here. We've got the x t plus 1, t1 or tn plus 1, tn, so we just need the difference in x squared. So how do we do that? Well, equals plus the difference squared. What have I done wrong? Okay. And then we want the change in y position and then what we want is the distance. So we know that the distance equals the change in x squared plus the change in y squared. We take the square root and we raise it to the power of 1/2, and we can see here that between 0 and 1 second the animal moved, or the beetle in this case, moved about 176 pixels. So we do that for all of the time points, and then we've got it for all of the time points here. And what we can see is that he's moved 176 pixels, 124 pixels, but then we notice that there is a couple of seconds here where it doesn't move much at all. 6 pixels, 8 pixels, 6 pixels. And if we have a look at the x and y position, yeah, see, 206, 209, it doesn't move much here. And remember, that's because he got stuck in the corner, in that bottom left corner of the video. So everything seems to be marrying up quite well. So how do we get the total distance travelled? Well, we just add up all the distances for each of the time points. So equals sum. Now I'm writing this in German, so you would have to calculate your own sum if you're using English or another language. So we need the sum of all of these values here. And what we can see is that the total, so in 12 seconds from 0 to 11, or in 12 data points, he moved 855 pixels. We have the coordinates of the arena, and so now we know that between here and here we've got 30 centimeters in each direction. We can now convert this using these arena coordinates. Now this is using Excel. This is not the best way of doing this, but what I'm trying to do is show you the general thought process on how to calculate the mouse's position, the distance the mouse or the beetle or whatever it is that you're measuring has moved for each time frame that you have analysed. Okay, I'll leave this one here.